Space is not the final frontier. You don't need to go that far to explore strange new worlds, to seek out new life. There are alien worlds right under our noses. Insects. As close to an alien life form that we'll ever see without leaving planet Earth. They've been around for well over 400 million years. Insects were watching when our distant ancestors took their first footsteps on dry land. They saw the dinosaurs come and go, and witnessed the rise of a smart, two-legged ape who thinks it rules this planet. But think again. This planet is run by insects. They're crucial to almost every ecosystem on land. Without them, our world would fall apart. This is their world and their story. The sheer diversity of insects is astonishing. About 1 million species are known to science. But, best guess, at least another 5 million are out there, as yet unseen by human eyes. At least 2/3 of all animals on the planet are insects. Or, as one renowned biologist said, to a good approximation, all species are insects. We may never know the true number of different kinds of insects on planet Earth. But one thing is certain, they're the most successful group of animals to have ever lived. What's the secret of their world-conquering success? One big reason is that their bodies can evolve almost any form you could imagine. As well as some that seem, well, beyond imagination. In just one rainforest, there could be 2.5 million different kinds of insects, all shaped to fit their own unique lifestyle. When it comes to all the ways in which insects have adapted their bodies, design flexibility seems something of an understatement. Insects hold dominion over dry land and fresh water, even beyond the teeming world of rainforests. The ultimate bug-eyed monster, a dragonfly larva. A perfect example of how insects can reshape any part of their body. It's the only insect that's jet-propelled. It squirts water from a very muscular backside, and it patrols its world like a tiny submarine. A hunter-killer submarine. At the opposite end from its jet engine, it has sharp eyes with stereo vision. It judges the exact distance to any unwary creature. And when it sneaks close enough, it deploys a unique dragonfly weapon. It's reshaped its mouthparts into an extendable trap that can shoot out nearly half its body length. And snap closed. A precision shot, over in the blink of an eye. Being able to customize any part of their body isn't the only reason for the triumph of insect kind. We've recently discovered something even more surprising about insects. It turns out that some are really, really smart. One test of intelligence in animals is when they're given a problem, they can work out a solution in their heads. Hang a piece of food from a perch, out of reach, and a smart bird like a raven soon works out what to do. Just pull the string, hold it with your foot, pull a bit more, and in no time at all, you have a snack. Yet anything a mere vertebrate can do. Bumblebees can also do this, even though they must be trained to solve the problem. Pull the string and reach a reward of nectar. Now, this bee hasn't been trained at all. But if she's allowed to watch her nestmate solving the problem, she knows exactly what to do when she gets her turn. Teachers and students, and all with brains only the size of pinheads. Combine this with the flexibility of the basic insect layout, and there's not much that insects can't do. Or places they can't go. They now live in every habitable spot on the planet, as well as quite a few that, to us at least, seem totally uninhabitable. White Sands, New Mexico. A sea of dazzling white dunes. Not a familiar silica sand, but gypsum crystals. Yet it's home to darkling beetles that survive searing temperatures. The ground can reach 120 degrees Fahrenheit. Insects have adapted to these extreme conditions in a relatively short space of time. These dunes are at most only 10,000 years old. Yet all kinds of insects are now perfectly at home in this desolate world. Gypsum crystals are much bigger than grains of silica sand. Yet harvester ants manage to dig their nests here, among what must seem like boulders to them. Under cover of darkness, even stranger creatures emerge. Sand treader crickets. Their back legs have evolved spiny shovels to kick the crystals away from their holes. Though even the best adaptations are never foolproof. Is there anywhere too harsh for an insect? The dead of winter, a world of snow and ice. Even here, some insects are in their element. Snow fleas. They are related to fleas, but instead of hiding in warm fur or feathers, they're out and about in the middle of winter. They don't even like sunny winter days, sheltering under the ice until the cold returns. And from the dazzle of dunes and snow to the darkness of a deep cave, it's just another place to call home. Cave crickets. This far underground, it's pitch black, but still no problem for insects. Cave crickets have absurdly long antennae to feel their way around in the dark. Anything that gets lost down here is soon found. There's not always much to eat. So when something tasty does turn up, it's worth fighting over. You never know where your next meal's coming from in this dark world. Insects are nature's ultimate success story. But some have done better than others. There are just a few thousand kinds of mantises, or stick insects. For others, their numbers are off the scale. Of all insects, beetles are the most successful. There's nearly 500,000 different sorts that we do know of, but a lot more that we don't. Around 1,000 different kinds have been found in just one sort of rainforest tree. And there are a lot of trees out there. Nearly half of all insect species are beetles. That means a quarter of all animals alive on Earth today are beetles. Everywhere you look, beetles and more beetles. Spring in a northern European woodland. A more familiar world. But still home to perhaps 1,000 different kinds of beetles. One reason that so many beetles can live in one place is that they've evolved a lot of different ways of making a living, of finding a bite to eat. A goldsmith beetle prefers earthworms. A glowworm beetle eats only snails. In the canopy above, a dendroxina beetle specializes in hunting caterpillars. Happy to gorge on those even bigger than itself. Just 3 unique lives among many in this one patch of woodland. And they all pass unnoticed. But the more we look, the more we find. Butterflies and moths are not far behind beetles in sheer variety. One in every 10 animals alive on the planet is a butterfly or moth. Surely everyone loves butterflies. An infinite palette of colors and ornate patterns, all created by a mosaic of tiny scales covering their wings. And there are still thousands more species that we have yet to see. Hidden beauty yet to be discovered. Museums around the world already house 160,000 different butterflies and moths. But every year, we find another 800 new ones. Maybe not as welcome, flies are another insect triumph. There are nearly 160,000 different kinds that we already know about. But that's nowhere near the whole story. Recently, in just 1 year, 30 new species were discovered within the city of Los Angeles alone. So it might be there are even more flies than beetles. But they're not as popular as beetles or butterflies, so fewer people are searching for new ones. Which is a shame, because they're just as beautiful if you look at them in the right way. They're all miracles of microengineering. Precision-built and equipped with some pretty high-tech features. They have gyroscopic stabilizers. Their hind wings are reduced to long stalks with a heavy club at the tip called halteres that beat up and down as they fly. At the base, there's a complex arrangement of tiny sensors that measure stresses along the stalk. These little knobs behave like gyroscopes. They always beat in the same direction. As the fly's body turns, the halteres don't. Instead, they bend and twist at their base. And the sensors read this information and send it to the fly's brain. So a fly has continuous feedback on its flight attitude, on roll, pitch, and yaw. It has its own autopilot, giving it precise control of its flight path, no matter what hits it. Their mouthparts are just as beautifully engineered. Built like a sponge on a stick. For these flies, every lunch is a liquid lunch. Bugs usually get a bad press, especially the ones that exploit us and our way of life. Look at it another way. Maybe we should admire how they profit from any and all opportunities. Left unnoticed, many generations of bean weevils live out their lives in a jar of dried beans. Their whole world as their larvae grow from egg to adult inside a single bean. Beetles do just as well in our world as in remote rainforests. There seems to be a beetle that eats every kind of grain we store. Flower beetles, rice weevils, golden spider beetles, on the other hand, eat just about anything, from pasta to mouse droppings. Any recipe works for them, even the recipe book itself. Insects have conquered the world, theirs and ours, because their basic body design is so flexible. And that's mainly down to one feature of their architecture shared by all insects. They have a hard outer skeleton, an exoskeleton. It's an insect equivalent of plastic. It can be molded into all kinds of shapes for all sorts of purposes. from camouflage to combat. The exoskeleton can be shaped into intimidating weapons. Many beetles grow horns, like miniature dinosaurs. A male atlas beetle is armed with opposing horns that work like a vice. At 3 inches long, these beetles are intimidating. And they use their horns in a trial of strength with rivals. Like sumo wrestlers, each tries to lift his opponent clear of the ground and throw him from the field of battle. But that tough exoskeleton means he'll live to fight another day. A strong suit of armor also protects insects from the elements. The exoskeleton is so water repellent that raindrops just bounce off. The colorful scales covering a butterfly's wing are made of the same stuff as the rest of the exoskeleton and are just as unwettable. Droplets simply roll away, keeping these aerofoils in perfect shape. We know the very first insects to evolve already had an exoskeleton. But we still have no idea what those first insects actually looked like. We can find a clue, though, in this lake on Mexico's Yucatan Peninsula. Sink below the surface, and this small pool opens into a vast network of flooded caves, a lost world. And in the deepest recesses, hidden from all but the most intrepid scientists, there are creatures that we thought, until recently, only existed as fossils. Remipedes. They look like swimming centipedes, but they're crustaceans, although not like any other on the planet. We know now that these particular crustaceans are the closest living relatives of all insects. A glimpse of how the ancestors of insects might have appeared. They lived in an ancient ocean and had long bodies with lots of segments, each protected by an exoskeleton. And lots of legs. Great for swimming, but just as good for walking on land. Armed with a waterproof and rigid case and legs for walking, creatures like these invaded land on 3 different occasions. First were the centipedes and millipedes. They kept all those legs, somehow coordinating them to walk. Next onto dry land were the spiders and scorpions. They'd reduced hundreds of legs to just 8, much more manageable. Insects were the last to venture onto land. Last but not least, they soon outnumbered all the others. Insects kept even fewer legs, just 6. Yet their legs are another vital part of the insect blueprint for success. Obviously, they're useful for walking or running. And a cockroach can certainly run. It's one of the fastest things on 6 legs. To our eyes, it's just a blur. But slowing it down 40 times reveals a neat trick. It keeps 3 legs on the ground at any one time, forming a tripod, the minimum number for a stable base. With 6 legs, an insect steps from tripod to tripod, which keeps it rock steady. Their legs also give roaches all-terrain capability. But just using legs for walking is a bit of a waste. They're much more useful than that. Late winter in Namaqualand, in southern Africa. The rains have triggered one of the most spectacular displays of flowers anywhere on the planet. Among them are twin spurs, which have 2 long tubes, or spurs, that extend below the flower. It's the favorite flower of one of the strangest-looking bees in the world. A female oil bee has ridiculously long front legs, much longer than the rest of her body, for a very good reason. She collects oils made by twin spurs to mix with pollen to make food for her larvae. But the oil is only found at the very bottom of the 2 spurs, where only a bee with really long legs can reach it. Having 2 long legs an oil bee can insert them into both spurs together and collect oil twice as quickly. As complex a docking maneuver as any carried out by NASA astronauts. At the other extreme, mole crickets have converted their front legs into short but broad and powerful shovels. They look very much like the feet of moles. Clearly, evolution isn't afraid to recycle a good idea. They can dig quickly, excavating long burrows under the soil. And like moles, they grab worms that break into their tunnels. A welcome addition to their diet of roots. The great thing about having 6 legs is that the front 2 can be converted into all manner of useful tools, still leaving 4 to walk on. Not as stable as 6, but still no problem. Mantids have converted their front legs into jackknives edged with sharp teeth, the weapons of a lethal hunter. Like any good hunter, it keeps everything clean and polished, ready for action. And with sharp eyes, it can spot the slightest movement. The rainforest is no place to be a small, tasty insect. And neither is this tranquil-looking pond. A water stick insect has evolved the same technique. Like the mantis, it has sharp eyes. And front legs designed to grab prey. It also has a sharp beak that stabs through the exoskeleton of its lunch. It injects toxins and digestive juices to dissolve the body of its prey, turning it into a hearty soup. Walking on water doesn't need a miracle in the insect world. Water striders stride over water. Their legs are so densely covered in hairs, they're unwettable, so they don't break through the surface film. The trick to surviving here is regular maintenance. Any dirt would destroy the waterproofing and the strider would sink. The surface film is a busy place. A water measurer doesn't so much stride as use long, thin legs to step carefully over the surface, like a novice ice skater. For any creature not specially equipped, the water surface is a lethal trap. Even large insects are held fast by the surface film. And struggling just catches the attention of the water walkers. Water striders only walk on their 4 back legs, so their front legs can be used to subdue trapped prey. It doesn't take long for a dinner-time scuffle to break out. Water measurers don't have the strider's powerful front legs, so they wait until the prey has almost drowned. This means the desperate struggles of a trapped insect won't damage the measurer's thin legs and body. Then, like a tiny leopard, it hauls its prey up a stem, away from the frenzy on the pond surface, and away from the dangers that lurk beneath. The water walkers might have mastered life on the surface film, but even they must be wary of monsters that swim below. Backswimmers are also predators, big enough to kill striders, but only if they can catch one. Striders can also use their long legs to jump, and for them, the surface film is like a trampoline. Backswimmers have turned their back legs into oars for rowing through the water. The paddles on their hind legs are made of a fringe of hairs that opens out on the power stroke to provide thrust, and folds down on the recovery stroke to reduce resistance, just as rowers feather their oars on the return stroke. With legs this powerful and a little bit of luck, backswimmers can drag an unwary water strider below the surface, where a predator becomes prey. Versatile legs played a big part in the insect success story. But another innovation really launched them to world domination. they discovered the power of flight. Not that long after they conquered dry land, insects conquered the air. Every year, around the margins of ponds and lakes, that momentous event is replayed. A dragonfly larva leaves its home beneath the surface. It was the terror of the pond. It will soon become a master of the air. Its wings are structures of delicate beauty. Shaped to harness aerodynamic forces in ways that we're only just starting to understand. Wings played a major part in the insect's rise to domination. And not just by lifting them into the air. Atlas moths have some of the largest wings of any living insect. And like all moths and butterflies, they're covered in tiny scales that form intricate patterns. The markings on these wingtips bear an uncanny resemblance to a cobra. When viewed up close, maybe it's enough to convince predators to leave well alone, just in case. But from the start, the most important thing about wings is that they allowed insects to take to the sky. The first insect flyers looked a little like modern dragonflies, though many were much larger. Some had a wingspan of over 2 feet. Those ancient swamps must have been amazing to see. Even today, dawn over the marshes reveals a spectacular sight. These dragonflies have spent the night in this patch of reeds. They chose their roost carefully. It catches the first rays of the morning sun, warming up the dragonflies until they're ready for flight. Insects had the air to themselves for 140 million years, until they were joined by pterosaurs, bats, and birds. All these creatures have a very different body plan from insects. They have an internal skeleton. This allows them to grow much larger than even the biggest insects. These new super-sized flyers soon made short work of the ancient giant insects. Today, insects still face finely honed aerial predators. Hobbies are small falcons with the aerobatic skills to hunt down dragonflies in flight. But insects have also sharpened their own aerial ability. A hobby misses as many as it catches. Insects evolved flight 400 million years ago. They've had plenty of time to perfect the art of flying. Hummingbird hawk moths fly and hover with all the skill of hummingbirds. But as good as these moths are, they're not the best. The top guns of the insect world are flies. Even the humble greenbottle can outperform most other insects. Males chase and grab females in flight, even if that means flying upside down. They're called flies for a very good reason. They can really, really fly. Look close enough, and this small world is filled with wonder. Even the most familiar, the most unloved, reveal hidden beauty. And we've hardly even started to explore Planet Insect.